Hi everyone. In this video, we're going to see about array and linear search in data structure. Here, we're going to discuss about what is an array, need of array data structures, characteristics of array data structures, types of array, array operations, and introduction to linear search, algorithm for linear search, and code for linear search. Okay, what is an array? An array is a collection of items of same variable type that are stored at continuous memory location. It is a way to organize and store multiple items of same type in a single structure to make it easy and to manage data effectively. Consider here the memory location starting from 200 and it goes on. Here the index value considered as a 0, 1, 2, 3, 4, 5 and 6. The value was U, B, F, D, A, E, C. So think of an array as a row of boxes where each box holds one piece of data like numbers or words and it identified by its position or index. For example, imagine you have a 5 friends and you want to store their names together. Instead of writing them separately, you can use as an array like this. Friends is an array name and the values are Arun, Babu, Clement, Darun, Ilango. Now you want to know the second friend name. You can simply use friend of one which is use Babu. Remember, in most programming languages, array starting count from 0. Need of array data structures. Storing data for processing. Implementing data structures such as stack and queue. Representing data in tables and matrix. And creating dynamic data structures such as linked list and trees. First, we're going to see about what is storing data for processing. Array helps store multiple values of same type on one place. Make it easy to process data effectively, like a list of student marks. Next one, implementing stack and queues. Array provides a foundation for building other data structures like stacks and queues. The next one, representing data in tables and metrics. You can use array to organize data in rows and columns, like a table of students' marks in different subjects. And finally, creating a dynamic data structure. Array are often the first step to build more complex structure like linked list and trees, which help in advanced data organizing and processing. The next one is characteristic of array data structure. Here we're going to see about homogeneous element, continuous memory allocation, zero-based indexing, and random access. So what is homogeneous element? All items in an array must be of same type, like a list of only numbers or only names. You cannot mix them. The next one, continuous memory allocation. Array store their items side by side in memory, like books arranged on one shelf after another. The next one is zero-based indexing. Most programming languages start counting an array position from 0. For example, the first item is at the position 0, the second item at 1, and it goes on. Then final one, random accessing. You can directly jump to any item in an array using the position, that means index value, making it super fast to find or change specific any item no matter how long the array is. The next we're going to discuss about types of array. We have three types of array: one dimensional array, two dimensional array, and multi-dimensional array. In one dimensional array, the array stored a single row of an element, which is given in the picture 1. The next one is two-dimensional array. Elements in a two-dimensional array are accessed by using two index. One, the row, the another one is column. Then we're going to discuss about multi-dimensional array. Multi-dimensional array are used to store multi-dimensional array. A multi-dimensional array is like a table or grid where data is organized in rows and columns. For example, a two-dimensional array can store students' mark for different subjects, where each row represents a student and each column represents a subject. If we go beyond two-dimensional array, it's just like adding more layers to the grid, like organizing data in cubes or more complex shapes. Next, we're going to see about array operations. There are different type of operations in array. One is traversal, insertion, deletion, and searching. Traversal, which means visiting each element of an array for in a specific order. Next one, insertion. Insertion, adding a new element into an array at a specific index. Next one is deleting an array. Deleting means removing an element from an array at a specific index. Searching. Searching is nothing but finding a index of an element in an array. Here I denoted a syntax for array. First one data type, the next array name, the next one array size, and we used to represent a values in array. Now we're going to see an example program how to create an array. First step, initialization. First we're going to create an array with the name of LA and the size is 3. Here with the 3 elements is created and initialized as 0. A loop variable I is declared for using in the loop. The next one is printing our array before insertion. The program first print the value of an array LA before any changes are made. It uses a loop to go together each position in an array and prints. For example, LA of 0 equal to 0, then LA of 1 equal to 0 and LA of 2 equal to 0. Inserting a new elements. Inside another loop, each element of an array is updated with the value I plus 2. For example, when I equal to 0, LA of 0 equal to 0 plus 2 equal to 2. When I equal to 1, LA of 1 equal to 1 plus 2 equal to 3. When I equal to 2, LA of 2 equal to 2 plus 2 equal to 4. Printing an array after insertion. After updating an array, it prints the new values. For example, the output is given here, where before inserting an element, the array size is up to 0 to 2. Total size of the array is 3 and the values are 0, 0 and 0. After inserting the array element in each index, the values are 2, 3 and 4. Next, we're going to see about linear search. Linear search is a way to find an element in a list by checking element item one by one, starting from the beginning until you find where you are looking for or reach the end of the list. For example, if you are looking for a specific book on a shelf, you check each book in order until you find the right one. It's a simple and works for any list, but it might take long time. Algorithm for linear search. The following steps should be followed in linear search algorithm. First one is start, compare, found, move, repeat, and finally if the element is not there, we use not found. The algorithm of the linear search can be broken down into following steps. Start, beginning the first element of the collection of element. Then compare. Compare the current element with desired element. Found, if the current element is equal to the desired element, return true or index to the current element. Move, otherwise move to the next element in the collection. Repeat the step 2 to 4 until we have reached the end of the collection. If we search through the entire list and do not find the item what we are looking for, we simply conclude that the item is not in the array. And finally, we return The result not found. Here, the simple code for the linear search. Loop through an array. The loop goes from the first element I is equal to 0 to the last I equal to n minus 1. Each element in an array is checked one by one, checking if element match. If the current element A of I matched to the data what we are searching for, it print for the position where the element is found and exit the loop by using break. Element not found. If the loop finishes, that is I equal to n, and the element was not found, it print that the element is not found in an array. Thank you. Thank you.